Welcome to Three Inquisitive Kids. In this video, we're going to be solving a problem using the trivial inequality. If you don't know, the trivial inequality is this. X squared is greater or equal to 0. This is just saying that the square of any number will always be non-negative. And believe it or not, this inequality can help us in the most complicated problems. So here's our problem. We want to find the only value of d, where a squared plus b squared plus c squared plus 1 is equal to d plus the square root of the sum of abc minus d. So we see something that's underneath the radical. Let's substitute in a new variable to simplify what's under the radical. So let's let x equal a plus b plus c minus d. And because this is all the content that's inside a radical, it must be greater or equal to 0. X is greater or equal to 0. It's a good practice to always define the set of all possible values that your new variable can be when you are setting up a new variable. So then our equation becomes the left-hand side does not change, but the right-hand side turns into a plus b plus c minus x. This is what the original d turned into. And then we have the plus square root of x. Now let's move all the terms to one side of the equation. We get a squared minus a plus b squared minus b plus c squared minus c plus x minus square root of x is equal to 0. And look, we have a very beautiful symmetric, almost symmetric equation. We always have the square of a number minus the number. Oh yeah, and we forgot to write the plus 1 is equal to 0. So in order to be able to apply our trivial inequality, we have to have something in the format of a parentheses squared. So how can we do that? Well, we can complete the square for each variable. The a squared minus a, if we add 1/4 to it, we would get a squared minus a plus 1/4. This would equal a minus 1/2 squared. But remember, we added on this extra 1/4, so I'm going to subtract it. Which means that this expression will eventually turn into this. Now we're going to do that for every single variable. So we get a minus 1/2 squared minus 1/4 plus b minus 1/2 squared minus 1/4 plus c minus 1/2 squared minus 1/4 plus square root of x minus 1/2 squared minus 1/4. And don't forget the plus 1. Now we have some extra minus 1/4. But that's all right because they're a constant and constants are easy to handle. And if we notice here, we have 4 of the negative 1/4 that cancel out with a positive 1. So we are left with 4 perfect squares added together equaling 0. So now we gotta apply the trivial inequality. A sum of squares of real numbers can only equal 0 if every squared term is 0. So each of these terms must be 0. Which means a is equal to 1/2, b is equal to 1/2, c is equal to 1/2, and the square root of x is equal to 1/2. This also tells us that x is equal to 1/4. Now let's use what we know to solve for d. Earlier we said that x was equal to a plus b plus c minus d. So d is equal to a plus b plus c minus x. So we have a plus b plus c minus x. And that gives us 3/2 minus 1/4, which is 5/4. So it turns out d is equal to 5/4.